Next is Hakima Chaouchi from Telecom SudParis in France, and where she leads the research group on emerging networks and services focusing on mobile communications and IoT technologies. She'll be talking about distributed core network from 5G centralized to resilient 6G.
Thank you.
Welcome.
Thank you very much. And thank you for warming the room with the three metrics. You said reliability, robustness, and resilience. I'd like to speak actually now about the view from, I would say, researchers from network and protocol architect designers, and trying to translate what resilience means. And I thought it was good to represent the resilience from what is expected from the radio communication to do resilience, and what is it expected from the networking layers. And I believe that part of the answer is in the model of communication. Like, you know, when you are designing IETF protocols, you understand perfectly what does it mean a point-to-point communication and what does it mean end-to-end. When you do end-to-end communication, so you cross intermediate nodes. So I believe that when we speak from the radio communication part, we speak point-to-point, meaning that you have the device and then you have the base station. And this is absolutely important to agree on before going further in the discussion. Okay, quickly, I mean, Institut Mines Telecom is a group of 8 engineering schools and 1 business school, and we are very much linked to the industrial research, innovation and competence needs. And we have been very lucky, I think, since COVID, as there was a very important program on research in different domains. And for digital, we had actually a very, very interesting programs on digital sovereignty. And one point here about academics, we, as Institut Mines Telecom, we get ourselves also organized in order to capture the understanding of innovation and research from the industry. Typically, when we speak about resilience, we need to have our researchers to get the requirements in the research projects, because it's not the same way to answer a question on, say, a high bandwidth for video streaming and answer the research question of resilience as what we are discussing here. So very quickly, in France, we are running a program which is a coordination and support action. It is called France CG, and I'm very happy actually to coordinate this action. And this is also a good way to bring from, I would say, the delegates from through GPP, the ongoing activities, and to inform the innovators and researchers about these, you know, very specific technical aspects ongoing in standardization. And now I would like to go again into this question of resilience. And as a researcher in networking, I need to understand how to measure that. So clearly, mathematically, we have the reliability model, the robustness, and then the resilience, which appears to be like the maximum expectation from the infrastructure. So then the answer actually, from my perspective, relies into this metric, which is not in the nice pictogram of 6G of ITU. It's called the availability. Availability of what? It's the availability of the service, which is offered by the network infrastructure. So if it is a point-to-point, so you need to measure this availability. If it's end-to-end, you need to measure this availability, okay? And here it is interesting to see the different metrics, what we call here, the nines, you know, the percentage of nines. And historically, of course, we have the legacy phone industry with a very strong nines compared to the internet industry. But internet industry from the IETF quality of service protocols have done great work to integrate quality of service of latency, bandwidth, and security. So I have there different tables, but probably resilience relies somewhere there, which is actually showing what is the system outage is allowed in resilience. I believe maybe in defense or military service, probably 0 is the outage which is allowed, right? And I believe that it is important to revisit the document and the models lying behind the availability, which is described by the ITU as one of the quality of service requirements in digital infrastructures. And what makes the difference to choose 2 nines, 3 nines, 4 nines? It's a cost. It's just a cost, okay? And I will not go through all this, but I find it interesting to try to understand, for example, the cloud software architecture. What is the availability of the cloud? Because, you know, we have an ongoing discussion currently on telco cloud, so we need to understand if the cloud, architecture is having the same availability as the telco architecture. And then I have other tables here, probably the one which is more interesting for us today is the one on 3GPP networks. The best thing to do is really to get back to the ITU document and really to analyze the models. My point here is really to remind that we need to have methods to measure the resilience and availability. These number of nines probably is one way to do that. Now, yeah, for defense, I leave it. Now, I was invited to actually speak about the SimpleRAN project. We have a poster tomorrow. And I thought it was interesting also to bring on the table the question of digital sovereignty. So, is resilience the enabling, I would say, technology or piece for digital sovereignty, or we need to have digital sovereign technologies in the whole, infrastructure, going from the application to the hardware, and then we need, of course, to have this available service in order to say that we are resilient. So here, I would like to speak about this project, which is called SimpleRAN. It is a French-funded project with a group of SMEs, actually innovative SMEs. It is coordinated by Amarisoft, who is running technology, virtual RAN technology actually. And then you have different players that I will show exactly in the architecture where they are standing. And from my side, I am the academic partner, and there is also another academic partner there who is Euricom. Euricom is this engineering school running open air interface in different projects at the European level. This is the architecture of SimpleRAN. Just to remind that the idea was to show that to have a digital sovereign infrastructure, you need to control the whole pieces from the device, the RAN, the access, and the core, okay? And here it is important to show that from the device up to, I would say, the core part, we are running 3GPP standards, which is fine. I mean, it's not a problem. But then, what you have on the application part, the device, what you have in the radio head, and what you have in the RAN, usually you install the RAN and the core, and you use the equipments that are available for the communication from the device to the core. Now we're speaking about resilience, so we need to understand the dependency that we have on these technologies, and that was the approach in this project. Actually, we did some analysis on what is the level of dependence that we have in this, end-to-end architecture. And clearly, at the European level, we're lacking these chips to be produced in Europe. But all the rest, like the equipment and the software, because there is a lot of work in SimpleRAN based on open source software, is made by these French SMEs. So these are like I would say, the parts that are not produced in Europe. So SimpleRAN is actually deployed either in 5G private network, but it is also deployed in some public installations abroad. And in NWC 2025, there was this, solution as what you can see for this dedicated private network that you can create as a bubble. So it can be used, for example, in tactical networks. And now I would like to go again into the architecture and how the SimpleRAN introduced the idea of putting more IETF on the device side. Why that was proposed? Because we would like to take advantage of IP protocols, mainly the routing, for example, in order to allow distributed, connectivity, and to be also into this objective of not having a centralized failure point as it is in the core, architecture of 5G. So it was proposed and implemented to have more IETF there, and we actually had different technologies introduced there. So the first one was the link between the radio node and the RAN, and here it is a standard. It's the ETSI-ORI. And here you have the French partners working on this module. It is running. Then there is this interface up to the access, and here you see we have the academic Eurocom with open air interface. We have a Marisoft running here the gateway between the radio part and the access. And here we have the processing of the data, and this is absolutely interesting because in SimpleRAN we introduce the possibility to use a software which is not necessarily the GAFAM software. So there is this Vandalin solution which is doing similar, I would say, processing, AI processing as AWS, for example. So there is a good analysis in the website of SimpleRAN to show that. And we have the other parts is related here to the management of the complexity which is in the core, and here the software is SlapOS. It is the OSS of this private 5G. So this is to show that all these technological pieces are developed and are running using developments of these SMEs. And finally, here there is an important point which is related to the privacy and the implementation of the European GDPR, and we have here partners developing solutions that are related to open hardware device, but also removing, the Google notification. So it's fully, it's a de-Googled device. It's called de-Googled device. So it's private here, and then regarding the poster of tomorrow. It presents this part of the technology that we call the SimpleRAN, and the SimpleRAN here is actually implementing the idea of distributing the core within the access part. So you have also within this technology line a player which is called Atem, specialized in the compression of video. So the production of the video packets is also software which is developed by this SME. And then going to this objective of SimpleRAN to distribute the core, as you can guess, the idea is into the analysis of the architecture, 3GPP architecture, where we have the run and the core functions, mainly the authentication function, the mobility, the session management function, localization function, I didn't mention them here. They are actually centralized, and one of the reasons actually is that for the authentication and the billing, you need to have a centralized approach. But here we're speaking about a need to have a resilient functioning. So the first element to identify in the architecture, which is fragile, is this centralized core with these functions. And what we have shown in SimpleRAN is that we can distribute the core, but we need to have, I would say, a network configuration change in order to have local core into these run nodes to be identified by the devices as being at that moment the reference core, and then this core can move. How can we do that? Thanks to the internet ad hoc routing protocols. It was mentioned today, the MANET, and we are in fact running a demo also in France to show this 5G, distributed 5G core, and we believe that this is a design principle for the future 6G architectures. So here I go quickly, and you will have more details with the poster tomorrow. We have, as I said, different technology pieces that are developed by these different SMEs. This is already a product, it is running. And from the research perspective, what we are interested in is to push this idea of distributing the core when considering other technologies like NTN. Because as we said, if we speak point to point, okay, a device connects to a base station which is terrestrial or which is NTN, then it is a direct line. The resilience is going to be defined by the physical radio link. But if we have a multi-hop, like if I go via a terrestrial base station and then I go to NTN, there you have the routing questions. You have a networking view to implement the resilience. So we are interested in this, and we are working actually now that we have validated the first part of the project, showing that using the MANET ad hoc protocols is ensuring the continuity of the service of the core. And we are also looking at a specific implementation by a partner of the project who is actually the inventor of Babel ad hoc routing. So he was involved in this part of the project, because what you could imagine that is an issue is how to ensure the authentication and the security when we have this distributed core. As I said before, the centralized core is guaranteeing this centralized authentication. But of course, there are techniques that we can own from the IP internet standards to do that. Here is just to show you an interesting point about the failure of links that are actually related to the number also of nodes. If you have bigger number of nodes connected, you have more chances to have a failure. So resilience is also related to that. And I finish here with the link to the presentation and the key takeaway. Thank you. I saw you standing.
Yeah, thank you for the interesting presentation. I have one question about this distributed core. I mean, I get the point that, you know, the AMF, SMF, they are all centralized. And so if you take one of them out, the the core network basically goes down, and then, the connectivity gets impacted severely. But then, I mean, if we want to have, let's say, multiple copies of the core somehow, was there at some point a thought about this multi-operator core network where you have two core networks sharing one RAN, and then one is a dormant core which you can bring it up as soon as you realize that, okay, something is wrong with one copy of your core? I mean, just to understand, because it's not so easy to configure the RAN to have these kind of dynamic cores being brought up and brought down, unless you have multiple copies of those AMF IP addresses, SMF IP addresses, and you need to then basically rely on the RAN being able to establish the SCTP tunnel on the fly. So
yeah, thank you very much. This is a very good question. And in fact, because of that, the project is focusing on the private 5G because the dimension is smaller. And you are absolutely right. Like you have, when a user comes into one domain, there is a signaling there to say that the core now is running in this run part. So yes, we have this signaling which is necessary, and this, in fact, the idea is that you have mentioned about multiple cores, and then you have one which is the dominant, and another is like local, are ideas that we're also experimenting. But for the moment, what we have established in the architecture is that one user, it's like we have a signaling showing where the core is running at this moment.
Thank you, Hakima.
Thank you.